Hi folks, I know that there was some extra confusion around number 5, so I wanted to make this video real quick to just kind of walk you through the geometries and what's actually going on. I know I did that a little bit in class, but I could tell that there were a lot of you that were still really confused, so I wanted to give this to you to have as a reference, and if you are struggling with any of the math that goes on in this video, please reach out. So, for number 5, we're trying to find the magnitude of the velocities VA and VB given this figure. So I drew this for you in class, but my recommendation is to first start by identifying what VTOT X and VTOT Y is. So meaning break apart this giant vector into the X components and the Y components. So if I look at this diagram here, right, what I have drawn right now is this triangle. So same triangle, it's just one is not nicely drawn, but it's drawn on the diagram, the other one's not. So I can see that the angle I'm looking at, which is this angle here, is going to be this angle of 22.5 plus this angle of 26.5. So when we add those together, we get 49 degrees. So that's going to be the angle we're working with in our in our problem. I also know, because I don't have it written out, I also know that VTOT is equal to 6.72 meters per second. Let's go ahead and try and find VTOT Y. Remember, to do that, I'm going to have to use some trigs. So SOHCAHTOA tells me that since I'm looking at the opposite side, I'm going to be working with sine. So the sine of 49 degrees is equal to that opposite side, which is VTOT Y, over the hypotenuse, which is VTOT. Multiplying that over, I get VTOT. I'm going to write it in a different color. I get that VTOT Y equals VTOT times the sine of 49 degrees. VTOT is 6.72 meters per second. So we get that VTOT Y equals 5.072 meters per second. All right, finding our X component now. So VTOT X, following that same process, instead of sine though, we're gonna have cosine. So we have, so VTOT X is equal to VTOT times the cosine of 49 degrees. So 6.72 meters per second times the cosine of 49 degrees. So VTOT X, we get 4.409 meters per second. All right. So we have VTOT X and VTOT Y. We're going to use those later. So that's some piece of information for later. Now we're going to do something really similar using our VA. Now, we don't know everything here, right? We don't know the magnitude of VA. We don't know VAX or VAY. But we do know this angle theta here is 22.5 degrees. So here's what we are going to have to do in order to solve this problem. And this is kind of what I was talking about in class, during class today, all right? We're going to have to utilize this information in order to break up this giant triangle into smaller triangles. So here's one of our smaller triangles. So we have an angle, we have side lengths. Because we have an angle and side lengths, we can rewrite our information. So VAY. All right, we know, just like from above, it's on the opposite side, so we're going to use sine. So we have VA times the sine of 22.5 degrees. Now, we don't know what VA is, so I'm going to leave that as a VA, but I'm going to change this sine of 22.5 degrees to a decimal. So that way it looks a little bit more like a coefficient, because that'll be useful in a little bit. So instead, the sine of 22.5 degrees is 0.383. So VAY is 0.383 times VA. And similarly, VAX equals VA times the cosine of 22.5 degrees. So VAX equals 0.924 VA. Alright, so now we have the velocity in the x and y of vector A in terms of VA, because remember that's what we're trying to solve for is VA. Now I'm going to draw out vector B, but first I'm going to draw a dotted line of where VA was. So VA was about like that, and we're going to take this vector here to be VB. It's important to note here what we actually have going on. So I know, right, this here is V tot Y. And this here is V tot. We know this angle inside here which I'll call phi. That angle we know from above, right? That's that 23 degrees. We also know that this angle down here from earlier was that 49 degrees, and this is a right angle. Now I'm drawing all of this because what I'm trying to find out so we have VB, I'm trying to find VBX and VBY, right? So that's what I'm trying to find, meaning the angle I need is this angle here. So I'll call that my angle theta. So in order to find theta, we're going to have to do some geometry. So I know that the sum of all of the angles inside of a triangle are equal to 180 degrees. So I'm going to go ahead and add up all of my angles. So I have 180, because that's what it's supposed to be, minus 90 degrees, which is this angle here. So I'm going to check that one off. Minus 49 degrees, which is this angle here. I'm going to check that one off. Minus 23 degrees, because that's that angle up there. Alright, and all of this is equal to our theta. So if I were to plug all of that in, I'd get 18 degrees as our angle theta here. Now, this one is a little different because if we look at our angle theta, the opposite side is not VBY, it's VBX. So in this case, the sine of theta is actually VBX over VB. Right? The opposite side, so VBX, over the hypotenuse side. Meaning that VBX equals VB times that sine of theta, or sine of 18, because theta is 18. So VBX is actually going to be 0.309 VB. And similarly, we have the cosine of theta equals VBY over VB, right? Because that's that adjacent side. This is our adjacent side here, so we're going to use cosines, because so ka toa, right? AH, adjacent over hypotenuse. So that means that VBY equals VB times the cosine of 18 degrees. So VBY equals 0.951 VB. All right. So I know what we've done so far might seem a little disjointed. So let's go ahead and write out what we know. So we know that V tot is equal to that 6.72 meters per second. We know that V tot x is 4.409 and V tot y is 5.072. We also know that VAX equals 0.924 VA, and VAY equals 0.383 VA, and VBX, which we just found, was 0.309 VB, and VBY equals 0.951 VB. All right. So while this might seem a little disjointed to have lots of different things defined in terms of variables, remember all the way back at the beginning, right, we drew out this triangle here. This is our triangle that we drew out. And then the triangles we worked with were this green triangle, which has VAX and VAY. And then up here, this triangle here, which has VBY and VBX. So we can see that all of our x is our V tot x, and all of our y is our V tot y. So, scrolling all the way back down, we can say that we know V tot x equals VAX plus VBX. V tot y equals VAY plus VBY. And if we look, our BX and BY and AX and AY are both defined in terms of VA and VB, meaning we have two equations, two unknowns. So you're going to solve this using a system of equations. As a reminder, if you're like, oh man, I don't remember how to do those, systems of equations you can either solve using elimination, which is going to be more difficult here. Elimination is when you try to multiply the equations so that way like VAX and VAY like cancel each other out, right? Like that, you have to like multiply your equations by like a factor, right? So like maybe you have to multiply by this one by 2 and this one by 3 in order to get the same coefficients. The problem is you're working with coefficients that are decimals, so elimination is going to be a little bit more difficult. Instead, you're going to want to use substitution. So, in order to use substitution, you're just going to solve one of the equations for VA or VB. You pick, doesn't matter. Then, plug that solution into the second equation, the one you didn't solve for. Alright, so solving the first equation, you'll get like VA equals some stuff, and then in your second equation, you're going to plug in that, that stuff for VA. Alright, so that's how you're going to finish off that problem. Like I said, this one was really intensive, really difficult. That's okay. You likely won't have things this difficult on your AP exam, but I'd rather have you try out things that are really difficult now, so that way when you get to the stuff that is supposedly super difficult, it will seem a lot less difficult for you. Alright, I hope that this video was helpful. Please reach out if you still have further questions.